Now, today we are going to start with a new lesson in chapter 14, which is lesson 4, which is talking about area and the law of sines. In this lesson, we are going to find the area of any triangle and to use the law of sines. Let's start now with a way how to find the area of the triangle. One of the ways that we know it in geometry of how to find the area by saying half times the base times the height. So we assume that this is my base and this is the height. So the area is half the product of the base times the height. Now there's another way. Another way says that if you know two angles and a side of a triangle, sorry, if you know two sides and the included angle, you can find the area of a triangle. So here we have two ways to find the area of a triangle, half BH, or another way, that's if you know the two sides and the included angle. Let's see what will be the other way. The another way to find the area of the triangle is half B, this is B, so half B times C times the angle between them, or half A times C times the angle between them, or half A times B times the angle between them. If you find, and this is the second way or the other way of how to find the area of the triangle. So by now we know two ways, half BH or half times two sides times the angle of the included angle between them. Now, as you remember, this is H is an altitude that's perpendicular on the base. So half B times H or half B times C sine A. How we can, from where we bring this formula, we remember that if we have, the area is half B times H. And if we assume that this is an right triangle, so we can say that, and this is theta, so we can say that sine of theta is H over C. So H is C sine of theta. So that's mean here I can write the area of the triangle as half B C, but instead of writing H, you have to write C sine of theta. So this is a way that we find the derivative of this another way. So as you know before, we have two ways to find the area of the triangle, half BH or half BC sine A. So as we know, we can say that we can classify the triangles into two types. We can say that it is an right and non-right. The non-right, that's mean it could be obtuse or acute triangle. Now, what are the ways to find the area of each one? If you have right triangle, you can say that the area will be half b times the height h. And the other, this is hello, we have two ways. And the other way, that's area, is half b c sine theta. Now, if we assume that this is b, and this is my c here, and sine theta, that's the sine of the angles between them, which is 90, and sine of 90 is 1. So that's why we can say that is the same as half BH. So I means now that if you have a right triangle, one way only can help you to find the area because both of them are the same. But if you have now the non-right triangle, how can you find the area? To find the area, we can say the area here, half the base times the height. This is my base, and this is my height. Or the area is half BC sine the angle between them, which is sine angle A. This is here. So I means that if you have a right, you have only one way, half BH. And if you have non-right triangle, two ways, half BH or half BC sine of A. Let's have now an example here. Finding the area of a triangle. What is the area of a triangle ABC to the nearest 10th of square mile? Now here, in order to find the area, you have to check. Does it have the height which is perpendicular on the base? No. So I have to use the second way. The second way says that I have to see two sides, this one or this one, and they include the angle. No, it's not given. I have AB and they have AC and the included angle between them. So the area of the triangle will be half 10 times 5, the two sides, times sine of the included angle. So 25 sine 31 degree. Let's find the answer now. Which is 12.87 to the nearest 10, approximately 12.9. This is a way here how to find the area of the triangle. Right now, do you have any question?
No, teacher.
No, it's clear. No, teacher.
Okay. Let's have now another example. A triangle has sides of 12 inch and 15 inches. The measure of the angle between them is 24 degrees. What is the area of the triangle? So if you have now, as I told you before, if you have now two sides and the given angle between them, you have to use the area, you can find, the area of the triangle. So here now, we have a triangle here. $12 inches and 15, and the angle between them is 24 degrees. What is the area of the triangle?
It will be half times 12 times 15 sine 24.
Bravo. Half 12 times 15 comes the angle between them, which is 24. Then 6 times 15 times sine 24. Now, sine 24 will be 0.4 times 15 times 6. You get the answer as 36.6, and the unit here is inch squared. This is here the first part of our lesson, how to find the area of the triangle. Be careful that they must be two-sided and the included angle. Now let's go to the second part of our lesson. Here. In this part here, we have to see that if you have now an right triangle, and if we have now non-right triangle, how can we solve them? Now, I told you before, sorry, that for the right triangle, you can use, for the right, we have Pythagorean Theorem and the Trigonometric Ratio. These two only used for the right triangle. To solve the right triangle, we go to them. What about now the acute or the obtuse triangle? How can we solve them? How can we find the other sides or the other angles? Can we use the Pythagorean theorem? No. Can we use the trigonometric ratio? No. So there are new laws to find in order to solve the another angle. So what are they? Let's start now with the first one. Imagine now in your mind, if you have two sides, a non-included angle. Two sides now. Sorry. Are given. As an example, this one is a 3, and then this one is 4, and you have this angle, and you need to find the angle opposite side. I mean, you need to find this angle. How did you solve it in the right triangle? What did you use?
Teacher, what is that number?
Number 4 here.
No,
I mean that
opposite.
it's given, yeah, I mean that.
Oh, 4. Oh, then we're going to use the 10.
Which means the trigonometric ratios. Thank you. So here, so in order to solve the right triangle here, just a second, please. So in order now to solve the right triangle, and you have two sides and none included angle, you use trigonometric ratios. But if this triangle is non-right triangle, what you have to do, how can you find it? By using the law of sines. This is here. So be careful. Two sides, none included angle. If you are in right triangle, you have to use the trigonometric ratios. And if you have a non-right triangle, you have to use the law of sines. Now, what now if you have two angles and non-included side? Two angles, now be careful now, two angles and non-including side, such as like this here. Two sides like this side and this side, and this is numbers, okay? But a non-included angle such as this angle here. How can you find the side? The objective here is to find the side opposite angle. Like, wait just a minute, please. You have two angles and non-included side. I mean, like this side here, you have it as number 1 as an example, and you want to find the side opposite angle. You need to find this side. How did you solve it in the trigonometric ratio? In the right triangle?
Pythagorean Theorem.
Or
The
We can
ratio.
use
for the
all
ratio.
of them.
So we can
Definition
use
for-
the trigonometric ratios and the Pythagorean theorem. But here, before using the Pythagorean, you need to solve it by the trigonometric ratio. Because here you have you have this angle. So you can say tan of one of the angles in order to find the second side. So the trigonometric ratios are okay. If you have now non-right triangle, such as this triangle here, and you have these two angles, and you have the measure of this angle, you can say that's 5, and you need to find now this side. How did you solve it? Can you use the trigonometric ratios or the Pythagorean theorem? No. In order to solve the non-right triangle, we have here to use the law of sines. So the law of sines, as you see now, help me to solve the non-right triangle. If you have two sides and non-included angle, or if you have two angles and non-included side. We are going now to use the law of sines in order to solve these triangles. But be careful only in the non-right triangle. If you are in right, it's so easy. You can use the trigonometric ratio. Now, if you have now two sides, like this one here and this one here, or you can say like and an included angle between them. How can you find the side opposite angle? How can you find this side here? You will use the Pythagorean theorem, and you can use the trigonometric ratios. So here, in order to solve the right triangle, or if you have two sides and one included angle, and you need to find the side opposite angle, you can use it by the Pythagorean theorem or trigonometric ratios. What you have to do now, if you are in non-right triangle, what you have to do? We have to use the law of cosine. I think you know what I mean by from chapter in grade 9, you talk about the law of sine and law of cosine. But today now I will tell you when we'll use them. Law of cosine, if you have two sides and included angle. So now let's differentiate between them. Between this side and this side here. If you have now two sides and non-included angle, you have to use the law of sine. And if you have two sides and included angle, you have to use the law of cosine. Two sides and the angle is not included, law of sine. But two sides and the angle is included, law of cosine. And the last one here, that if you have three sides, and you need to find this angle. How did you solve it in the right triangle? You have to use the inverse of the trigonometric ratios. And if you are in non-right triangle, such as this one here, this is for 3, 4, 5, and you need to find now this angle as an example, you have to use the law of cosine. So the law of sine, the law of cosine, in order to solve the non-right triangle, and the Pythagorean theorem and the trigonometric ratio in order to solve the right triangle. Is it clear?
Yes, teacher, thank you.
Here you can change the name as inverse of trigonometric ratios or trigonometric ratios inverse. So on the other side. By the way, here to solve the right triangle, maybe you can add the new thing. This is actually I prepared. And I said yesterday, and I tell myself that if you have this are given and I want to find this thing, what can I do? So I can write tan specific or cosine or tan, but I tell you that trigonometric ratios. For the 3 sides, if you have 3 sides and you want to find, if you have 2 sides and you want to find the other side, in right triangle, you have to use the Pythagorean theorem. But in the other way here, if you have 2 sides only, you need an angle. And I mean, like yesterday, I think that if you have 2 sides and you need to find the third side, you can solve the right triangle by the Pythagorean theorem. But if you have it, if you know that this is 3 as an example, and this is 5, and you need to solve or to find this one, we need an angle. We must have an angle in order to solve A. Or I think that we can use law of sine and law of cosine at the same time in order to find the third side. So I think yesterday that if you have 2 sides and you want to find the third and the length of the third side without any given angle, it will be complicated. I think you have to use the law of sine and law of cosine. But if it is right, it's so easy. You have to use the Pythagorean theorem. So if you have anything, or if you see that I can edit this table or add something to it, tell me. Okay, because this is from my preparation. If you have something, if you see that something wrong, or I add something, tell me. So now in this lesson here, yes. Is there anyone who wants to say something?
No, I was saying okay, so I will take a look at this table. Thank you.
Yeah. Now, so in this lesson now today, we are going to talk about law of sine. Next lesson, we are going to talk about law of cosine. Let's start now with the law of sine. Law of sine, you have to use it in 2 ways. If you have 2 sides and non-included angle, or 2 angles and non-included side. Let's see now how can we solve it here. Find the side of a triangle. In the triangle PQR, now here, since they didn't tell me that R is a right triangle, so this will not be a right. This will not be a right triangle. So P QR. If the measure of angle R is 39, PQ is 40 centimeter. What is RQ? Now here, I want to see now what can I use? Here now, since we have two sides and an included angle, RQ, oh yeah. So I can use the law of cosine. And if you, by now, I don't know the law of cosine. I know only the law of sine. طبعا. Okay, just a minute. I'm sorry, I forgot to write what is the law of sine. If you have now this triangle here, A is the length of A, B, C, and this is here, the angle. Now, law of sine says that sine of angle C over the opposite length will be equal to the sine of angle B over its opposite length equals sine of A over its opposite side. This is here the law of sine. I can use two of them in order to solve the triangle. According to what did I have? Sine of C over C, or sine of B over the length of B, over sine of A over the length of A. And be careful, the small letter means the length of each side. This is here the law of sine. So here now we have 2 minutes left. Let's start to solve this question here. So here if we have P, Q, R, and the measure of R is 39, and PQ is 40 centimeter. What is RQ? Now here we know by now we know the law of sine. The law of sine, that's if you have two sides and non-included angle. Yes, this is two sides and non-included angle. So I can use the law of sine. Now, law of sine, I need side and its opposite angle. Another side and its opposite angle. And here, this is 32. Okay. If I don't know to solve this side, which is angle, which is side X here, I need now to find measure of angle P. How can I find the measure of angle P? If I know that measure of angle Q is 32 and measure of angle R is 39. So when I adding them, I use the triangle angle or angle triangle summation, that they are 180. So measure of angle P plus the measure of angle Q plus the measure of angle R will be 180. So that's mean the measure of angle P will be, just a minute, 39 plus 32 minus 180. So it will be 109 degrees. So now I need to solve to use the sine now. Sine of 39 over its opposite side, 40, must be sine of b, which is 109, over its opposite side, which is x. So sine of 39, we know it. 40, we know it. Sine of 109, we know it. We need to find x. So how do you find x? You multiply 40 times sine 109 over sine of 39. You will find that x will be 60 degree, approximately 60 degree. Tomorrow, inshallah, we will solve more examples in order to understand how you use the law of sine. Is it clear?
Yeah, thank you.
Yes,
Yeah.
Thank you.
Have a nice day.
Have a nice day. Thank you.
Have a nice day.